to think of the Disney Pixar movie called Cars. I want you to imagine Lightning McQueen as he's racing down the tractor in the Piston Cup Championship. What noise does he make? Well, it probably sounds something like this. As funny as it can sound, it's a fairly common sound effect, and many people can even recreate it if they've never been to a car race. But why does the sound like that? In other words, why can you hear both a higher pitch and a lower pitch as the car passes by? Well, this sound phenomena is called the Doppler Effect. The Doppler effect is the change in frequency or wavelength of a wave for an observer moving relative to its source. I know the physics definition can be kind of confusing, so I went ahead and with the help of my friend Adam made an example to show you. Cool, huh? Here's how this happens. As the car approaches me, the pitch of the engine sound was high, and then suddenly after the car passed by, the pitch of the engine sound was low. That was the Doppler effect, a shift in the apparent frequency for a sound wave produced by a moving source.
Excuse me, I have a question.
Yes, Gretchen.
So now that we know what this looks like in a real life example, how does that happen?
Great question. The Doppler effect is observed because the distance between the source of sound and the observer is changing. If the source of sound and the observer are approaching each other, then the distance decreases. If the source is going away from the observer, then the distance is increasing. The source of sound always emits the same frequency. Therefore, for the same period of time, the number of waves must fit between the source and the observer. If the distance is large between the two, then the waves can be spread apart. But if the distance is small, the waves must be compressed into a smaller distance. Here's a picture to visually show this phenomena. Here are two examples of sound waves. As you can see right here, when a source is stationary, the sound waves are all spread out evenly. However, the case is different for the car. As the car moves, it creates sound waves that spread out in all different directions. As the car moves forward, it moves closer to one part of the first ripple right here. After it makes it to the second ripple, two things have happened. In the front of the car, the ripples are bunched together, but behind the car, the ripples are spread apart. This is because the car moved away from that part of the sound wave. Okay. For these reasons, if the source is moving towards the observer perceives sound waves reaching them at a more frequent rate or a higher pitch. And if the source is moving away from the observer perceives sound waves reaching them at a less frequent rate or a lower pitch. Here's a picture to help visualize what is going on. As you can see, as the source, or in this case, the car moves towards the observer, the sound has a pitch that is perceived as higher. As the source is farther away from the observer, the sound is perceived as a lower pitch. It is important to note that the effect does not result because of an actual change in the frequency of the source. The source puts out the same frequency. The observer only perceives a different frequency because of the relative motion between them. Thanks for watching.
Lightning McQueen is gonna win the Piston Cup!
Now that we know what it looks like in a real life example, how does that happen?
Great question.
Oh wait, shoot, I can't switch the camera when I'm filming.
Or a higher pitch.
Oh my god.